Design of synchronous sequential circuits. The design of a sequential circuit starts from a set of specifications. We should obtain the state diagram and finally the circuit diagram. A synchronous sequential circuit is made up of flip-flops and combinational gates. Design procedure involves choosing the flip-flop type and combinational circuit structure which together produce a circuit that fulfills the stated specification. Number of flip-flops is determined from the number of states in the circuit. N flip-flops can represent up to 2 to the power n binary states. For example, 2 state requires a single flip-flop and 4 states requires 2 flip-flops. Design a clocked sequential circuit that operates according to the state diagram. Use D flip-flops. So this is a state diagram. We have 4 states 0, 0, 0, 1, 1, 0 and 1, 1. So we need to have 2 flip-flops and these are the inputs and outputs. First we need to create a state table. Then select 2 D flip-flops to represent the 4 states. The outputs of the 2 D flip-flops can be named as A and B. There is one input X and one output Y. The characteristic equation of the D flip-flop is Q of T plus 1 equals DQ. This means the next state values in the state table specify the D input condition for the flip-flop. Let's start designing the circuit. The state diagram is given and we need to write the state table from the state diagram. The state table consists of the present state, input, the next state and the output. So from the state diagram we can see when the present state is 0, 0 and the input is 0, it remains in the same state and the output is also 0. So present state is 0, 0, input is 0, it remains in the same state 0, 0, output is 0. When the present state is 0, 0 and the input is 1, it moves to the next state 0, 1 and the output is 1. So I write it in the table, present state is 0, 0, input is 1, the next state is 0, 1 and the output is 1. From the state 0, 1, we need to see when the input is 0, it moves to the next state 1, 0 and the output is 0. That has to be filled in the state table when the present state is 0, 1 and when the input is 0, next state is 1, 0 and the output is 0. Same way when the present state is 0, 1 and when the input is 1, it remains in the same state with an output of 0. So we'll fill it in the state table when the present state is 0, 1, when the input is 1, it remains in the same state 0, 1 and the output is 0. Same way we can fill in the state table for all the present states. We can write the respective next states. Now we need to write the input equations which can be obtained directly from the table using the minterms. So we can write for A of T plus 1, your D flip-flop A, input of D flip-flop A, we can write the minterms which is summation of M 2, 4, 5 and 6. And then for the next term, for the next flip-flop input DB, it is again a function of A, B and X. So it is the summation of 1, 3, 5 and 6. And lastly for the output, it is going to be the summation of 1 and 5. Let's try to minimize the expression using the K-maps. So here we need to draw the K-map for the D flip-flop A, D flip-flop B and for the output. So DA is a function of A, B and X. So from the K-map we can find out from the table we can see that it is summation of 2, 4, 5, 6. And using the K-map we can find out dA equals AB complement plus BX complement. For DB it is summation of 1, 3, 5 and 6. So we get the expression as DB equals A complement X plus B complement X plus AB X complement. And for Y it is summation of M 1, 5. So we can get it Y equals B complement X. So using the expressions that we just now derived from the K-map, we can draw the logic diagram like this. So here dA equals AB complement plus BX complement. A and B are the outputs of the flip-flop. So using that, we can draw like this using the logic gates. X is going to be the input, and for dB it is a complement x plus b complement x plus ab x complement, and we also have the output y, which is equal to b complement x. So thus we have designed the circuit. As an additional information, let us see how we can represent the state table in two different methods. So this state table consists of present state, input, the next state and output. Here we can see the present state 0, 0 is represented when the input x is 0 and when the input is 1 as two different rows. Same way with the present state 0, 1 is represented two times when the input is 0 and when the input is 1. So here in this table we have got 8 rows. We can also represent the same state table in a different method like this, where we have got only 4 rows. How is this possible? We have made the next state as when x is equal to 0 and when x is equal to 1. So when the present state is 0, 0, when the next state becomes 0, 0 when your x is 0, and it becomes 0, 1 when your x is 1. Same way we can represent the output when the input x is 0 and when the input x is 1. So the state table has reduced from having 8 rows. Now we are representing the state table using only 4 rows.